Hello, viewers and my dear students. Welcome to session 5 on projection of solids demo. We'll continue with demo on pentagonal pyramid, what we have started in the last session. See here, we were at this stage. That means we have drawn XY line, we have drawn VP, HP, and we have drawn one pentagonal pyramid in the top view, pentagonal pyramid in the front view. Okay, and name the corners and all that. And I told you how to get the apex point, that is perpendicular bisector, that will be O point. O1 is the axis, and you have 10 edges here, 10 edges here. 10 edges here are AB, BC, CD, DE, EA, OA, OB, OC, OD, OE are the slant edges, 10 edges. In that way, here you have base edges, here itself is 5 edges, plus 2 slant edges here, 2 slant edges here, 1 slant edge here. In that way, 10 slant edges are. And you have to carefully manage the axis. O dash, O dash is axis. It is not merging with any of the edges. It should be shown properly as light line, one big one dot. That is, you get in the representation. That is line representation. Okay, you take the axis representation. Okay, then height is 50. Okay, now I told you key tilting right will be corner on HP, tilting left is edge on HP. In this way, they have clearly given it is corner on HP with axis inclined at 40 degrees to HP. Okay, now as you know here, actually there is one command here. Here in this extend to next is there, no? Extend to next. Extend to next is there. Okay, I'll show you what exactly is that. Okay, extend to next is that. You see, it will extend to the next line, next obstacle, and it will extend till it meets the next line. Okay, okay. Now it was like this. I'll extend it to next. Extend to next means it will extend till another line is met. Okay, okay. Now I have done this. Put escape. Okay. Now, as you know, in the extend to next also, this a new command I wanted to show you here. Using extend to next, you do this, and axis is inclined at 40. And that is why I rotated this such that base is inclined at 50. Okay. Okay. I've extended. See carefully. Uh, this axis is inclined at 40 degrees to HP they are given. That's why I've inclined base inclined at 50. So that when this is 50, anyway it is 90 here at this, then when this is 50, this will be automatically 40. Okay, I'll dimension this. See here. Okay, 40 degree. Axis is inclined 40 degree. Okay, now you know very well it is corner and HP such that axis is inclined at 40 degrees to HP. Now, in this position, how it is seen in the top view has to be written. This is a problem inclined to HPVP. Now I have given HP inclination only. Next will be VP inclination. Okay. Now it is when it is inclined to HP, its top view changes. It will not be like this. The top view changes. That is the thing what you have to write down. Now you see here. I'll take 0.13. I'll draw the projector line. Carefully you see here. End point only you sense. End point only is sense. Draw this. End point only is sense. End point. Okay. End point, that is end point is sense, so that there won't be any errors. You sense the end point and draw this, and sense the end point, draw this, and sense the end point here, and draw this. Okay, now you see here, these extra things and all that, you can remove it off also. I'll just zoom it. Okay, this extra things and all that, you have a trim command. Using that, you trim all that. Okay, then again you fit it, and again I'm telling you, if you zoom it, the working environment will become easier, because you can sense endpoint, midpoint, and all that. Otherwise, it's difficult for you. What exactly is happening, you won't understand. You won't take the right points. Okay, now you are looking from the top. Okay, you have to draw the top view of this. Okay, now as you know here, first I told you, you get the point first. This point is O point. Okay, this is O. Okay, then this point, no, very good, intersection you are getting. Okay, see for intersection. Okay, but you have to see for intersection, then only it will be proper. Okay, intersection point I'm getting AB. Then this is end point anyway, easy. This is one point where you will get E. This is end point I get. This is C. Okay, this is D. Intersection point. This, if you don't get this, don't do approximately. It's better you zoom it. You'll definitely get it. Okay. Then anyway, from here also, this you got no. Okay. Uh, this you see here on the line. From here, no, from here, end point. Here on this line, actually, you should get the axis point. Okay, on this you should get axis point. Okay, now what I'll do now, first I'll get the coordinates. A, B, C, D, E, O, O1. Okay, I got all this. Now you see here, this A is here. A is here. B is here. Correct, no? B is here. This is C point. Carefully you do. C is here. This is D. This is E. Okay. This is E. This is O. Okay. O1 is here. I'll show that. I'll tell you later on. First, because these are all A, B, C, D are the base edges. OA, OB, OC, OD, OE are the slant edges. First, we'll finish off. Axis, anyway, it's an imaginary representation. We'll show it later on. Okay. Now, when you're looking from the top, okay, I'm looking from here. Apex is nearer than the base anyway. First step, as I've told you earlier, complete the outer boundary of these points. This I've told you so many number of times. Complete the outer boundary of this point. Complete the outer boundary of these points. See here, from here. See here, if you're not getting, I'm telling you, you better zoom it. This is the practical difficulty what you get. Otherwise, your points what you would have picked will be wrong. Okay. Now from here, this point you take, and this point intersection you get. Okay. This is end point you get. Okay. In that way, carefully select the point so that you are not doing any mistakes. Okay. Now you got the outer boundary. Outer boundary is okay. I fit it, and again I'll zoom it for my area. It's a little bit of zooming so that for better clarity I'll do. Okay. Now I have drawn the outer boundary. Since apex is nearer than the base, remaining edges of the base should be invisible. That is why what I'll do now, the remaining edges of the base will be invisible means E to D, E to D and D to C will be invisible. That is why what I'll do, I'll take this E to D, immediately go here. In the line types now, this only you should select. You make it dotted. Okay, in the same way, select this, go here and select this, make it dotted. That means now you see here, AB, BC, CD, DE and EA. 5 edges are over. Now DE and EC, why I have made it dot dotted? Because when apex is nearer than the base, remaining edges to the base cannot be seen after the outer boundary. Anyway, outer boundary you done. Remaining edges ED and DC. If base were to be nearer, I would have darkened the base. Okay. Now since apex is nearer, remaining edge of the base, that is far away edges cannot be seen. In that way, DE and DC. That's why you remember this as a procedure. If apex is nearer, after the outer boundary, which is the first step, in the second step, compare apex with the base. If apex is nearer, remaining edges of the base, make it dark dotted. Base is nearer, darken the base. That means 2 steps have already been completed. Now we are going in for the third step. Third step, whatever edges which are nearer to the observer are darkened and edges which are far away from the observer are made dark dotted. You are looking from here. And when you are looking from here, OB and OA can be seen, correct now? OB and OA can be seen. And D is a farther away corner. When you are looking from the top, this OD is blocked by the solid, cannot be seen. And then hence OD, you make it dark dotted. That's why when you are looking from the top, OA and OB should be seen by the observer. In that way, you see here, I'll darken this 0.5. See here, OA, OB, I'll darken it. Okay. And O to D, I'll draw and I'll make it dark dotted because D is a faraway corner when you're looking from that. That means OD cannot be seen. In that way, you select this edge and make it line type, this dark dotted. Okay, in that way, you have completed the solid. But see here, finer aspects are these things. Only for this, I'm giving you the demo. See here, axis is O to O1. This point is O1, correct? No, this point is O1. I think this point is O1 because O1 is here. But axis cannot be seen between O and O1. Okay, that is why what I'll do now, I'll split this line. I'll use the split command. Okay, I'll select this line and split at this so that the line is split at this, and you know very well it is only between here, only here it will be axis representation. That is why you show this one long, one big one dot line. That means you see here O to D is dot dotted, but D to O1 is axis representation. This is the finer thing what you should know. This you remember, please remember this. Only once you do these things, you will get 100% marks. See here, axis is not an edge. It's an imaginary separation. Okay, it's an imaginary separation. That is axis of symmetry it is. Okay, now O to O1 don't show the axis entirely. O to D is invisible edges. Invisible or visible edges are always preferred over axis. Now axis, though it is from O to O1, axis can be shown only between D to O1 only. Okay, D to O1 only you show the axis. Okay, now it is this. Now what you have to do is, you once you have completed this, okay, once you have completed this, the top view of the axis should be inclined at, top view of the axis should be inclined at 45 degrees to VP. That means O1 should be inclined at 45 degrees to VP. That, as you know, O1 is in true length here. But here, since it is inclined at 40, it is the reduced length. But what they said is top view of the axis should be inclined at 45 degrees to 40 degrees to VP, 45 degrees to VP. Okay. And they said you incline it at 45 such that base is nearer to the observer. You can incline it in such a way that apex is also nearer to the observer. But as you know very well, there is change of position method. Keeping inclination constant only, I'll rotate. I'll rotate over the pivot point D. Even if I rotate O this way or this way, if I rotate this top view in any position, the top view will remain same because the axis inclination to HP will not change. Okay, now we'll complete this session 5. We'll continue this in session 6. Thank you, friends. Thank you for watching. Thank you.